Hi students, in this video I'll be going through some concepts related to remainder the theorem, and then after that I'll end off by doing a O-level question. Alright, so to start off the discussion, we'll look at the division of numbers first. Okay, so let's say we are going to divide 16 by 5. Okay, so over here we need to know some terms first. Right, so this 16 is called the dividend. Okay, so the number that you're going to divide is called the dividend, and the number that you're going to divide by is called the divisor. Okay, so you're going to divide 16 by 5. Right, then we all know very well that we're going to get 3 because 5 can go into 16 3 times. So we're going to minus 15 and going to get the remainder of 1. Okay, so over here we're going to get the remainder, and this 3 will be called is called the quotient. Okay, so if you're going to write it out as a statement, then it's going to look like this. All right. So 16 is going to be equals to the divisor times the quotient plus the remainder. Okay, so over here we have the dividend. Okay, over here we have the divisor. Over here we have the quotient. And then over here we have the remainder. Right? Okay, so this also applies to polynomials. Okay, so let's say we have a polynomial called fx, and fx is equals to 2x cubed minus 3x squared minus 5. Right? Okay, and then we're going to divide this. Let's say the question tell you lah. Okay, that when you divide by 2x plus 1, okay, it has a remainder of negative 6. So has a remainder of negative 6 when divided by 2x plus 1. Okay, so over here this 2x cubed minus 3x squared minus 5 is the dividend. Okay, and this 2x plus 1 is the divisor. Okay, and then this minus 6 is the remainder, right? Okay, so if you're going to write out as a statement, it's going to look like this. So 2x cubed minus 3x squared minus 5. Okay, so remember dividend. Okay, so dividend is equals to divisor. Okay, so divisor is 2x plus 1. Quotient. Okay, the quotient we don't know. Okay, but it doesn't matter. Okay, over here we have the divisor as degree 1, right? Okay, so degree 1 times degree 2 okay, will give you degree 3, right? So over here we can just let it be ax squared plus bx plus c, although we can actually find out this ax squared plus bx plus c, the a, b, and c quite easily lah. Okay, then plus the remainder behind. So now it's plus negative 6, so we'll just write negative 6 over here. So over here we have the remainder, right? So we can express it in this form for polynomials. Okay, so remember this whole thing is equals to fx. Okay, so now if let's say the question never tell you what is the remainder, but they want you to find the remainder. Okay, we can find the remainder actually very, very easily, because all we need to do, let's say looking at the right hand side of this equation, right, to find this negative 6, right, we can make this whole thing equals to 0. And we can make this whole thing equals to 0 by doing something very simple. All we need to do is sub x equals to negative half. Why negative half? Why sub x equals negative half? Because when I sub x equals to negative half inside here, this whole thing over here, the whole divisor, this whole thing, right, will become 0. And 0 times the quotient will make the whole thing equals to 0, and we are only left with the remainder. Okay, so we can test it out and see. So all we need to do is replace x with negative half. Okay, so let's test it out and see. So let's sub x with negative half. Okay, so we'll be able to get okay, over here we'll get 2 times negative 1 over 8 minus 3 times 1 quarter minus 5. Okay, so over here we will get negative 2 over 8, which is negative 1 quarter minus 3 quarter minus 5. And then you see, we will get the remainder to be negative 6. And the remainder was negative 6, right? right? Okay, so now we're going to extend this concept to factors. Okay, what happens when you divide by factor? Okay, which is actually going to be even easier. Okay, so let's say you divide 16 by one of its factors, which is 8, then you will get 2, okay, and remainder 0. So if you write out as a statement, 16 will just be 8 times 2. Okay, there's no remainder behind, but if you want to add 0, that's fine, all right? Okay, so let's extend this concept, okay, to polynomials. Okay, let's say you have a polynomial px, right, equals to 2x cubed minus maybe 3x squared plus 1, and they tell you that it has a factor of x minus 1. Okay, so when you divide by a factor, so remember 8 is a factor of 16, right? So when you divide a number by one of its factors, you're always going to get remainder 0. Okay, so if we can write out this statement again, okay, so remember over here is the dividend, divisor, quotient, and then remainder. In this case, it's 0, right? Okay, so the dividend is now this thing, the 2x cubed minus 3x squared plus 1. Okay, the divisor is the thing that you divide by, so this is the divisor. Yeah, doesn't matter. Okay, the quotient, I can just let it be a squared plus bx plus c. Okay, plus the remainder 0. Okay, so let's say they didn't tell you that x minus 1 is a factor. They want you to prove that it's a factor or just say whether it's a factor or not. Okay, remember, I just want to make this whole thing equals to 0. And how can I make this whole thing equal to 0? I make this one equal to 0. Which means now I'm going to start x equals to 1. When x is 1, 1 minus 1, 0. 0 times this whole thing, the whole thing becomes 0. And I will just be left behind with the remainder. Okay, so let's try it. So remember this is px, right? So now I'm going to find x equals to 1, because when x is 1, 1 minus 1 will be 0. So now I find p1, right? So you see p1 is going to be 0. Okay, so over here we have 2 minus 3 plus 1, so you get 0. So p1 is 0. So indeed, okay, when I find p1, I get the remainder, which is 0. All right. Okay, so now let's take a look at O-level question. So this is the 2018 paper 2 question 8. Okay, and apply the concept that we just learned. So the equation of polynomial px is given by 2x cubed plus 5x squared minus 18. Find the remainder when px is divided by x plus 2. So to find the remainder, we divide by a linear factor, very easy. We try to find the x that makes this one 0 and then sub inside the px or the fx or whatever. Okay, so it should be quite obvious that x is going to be negative 2. So all we need to do is find p negative 2. All right. Okay, so over here you will get negative 16 plus 20 minus 18. So 4 minus 18, negative 14. So the remainder is going to be negative 14. So this itself is the remainder already. Okay, so you can write like this. Remainder equals to p minus 2 equals to this, right? Okay, let's take a look at this next part. Okay, show that 2x minus 3 is a factor of px. So remember, px is 2x cubed plus 5x squared minus 18, right? So if I want to show that 2x minus 3 is a factor, remember when you divide a polynomial by a factor or divide a number by a factor, you are going to get remainder 0. So to show that 2x minus 3 is equal to 0, I find the remainder where you divide by 2x minus 3, and then hopefully I get 0. Alright. So to get the remainder, remember, make this 2x minus 3 0. So x is equals to 3 over 2, and sub this 3 over 2 inside here. Alright. Sub this 3 over 2 inside the px. Okay, over here. So now I'm going to find p 3 over 2. Okay, so p 3 over 2 cubed plus 5 3 over 2 squared minus 18. Okay, over here you calculate, you get 27 over 4 plus 45 over 4 minus 18. Okay, if you do add up all this together, okay, you will get 0. Alright. Okay, so 60. Okay, so you'll get 61 plus 61 plus 7, 72. 72 over 4 is 18, and 18 minus 18 is 0. Right? Okay, so you can conclude that since P3 over 2 equals to 0, okay, the remainder when Px is divided by 2x minus 3 is equals to 0. Okay, alright. The remainder when Px is divided by 2x minus 3 is 0. So 2x minus 3 is a factor of Px. Alright. So to show that 2x minus 3 is a factor, I show that when I divide Px by 2x minus 3, my remainder is 0. Alright. Okay, so let's look at part 3. Show that the equation Px equals 0 has only one real root. So now we try to solve Px equals to 0 and show that it has only one real root. So remember, to solve a cubic equation, what we want to do is we want to factorize Px. Okay, so we want to factorize Px. Alright, so let's go ahead and try to factorize Px now. So remember, Px is 2x cubed plus 5x squared minus 18, right? Okay, so to factorize Px, we need to know one of these factors, which part B already helped us with already. Because part B, we show that 2x minus 3 is a factor. Okay, so remember, when something is a factor, it means that it's just over here, you see? See, x minus 1 is a factor of Px, right? So Px will just be x minus 1 times another quadratic factor. Okay, so it's the same thing for this. So it's just going to be, since 2x minus 3 is a factor, right, it's going to be 2x minus 3 times another quadratic factor. Okay, so to find a quadratic factor, it's very easy. Okay, we can actually do some observation first. Okay, so over here is a 2x cubed, right? So what we need to ask ourselves is 2x times what will give you 2x cubed? So it's quite obvious that it's going to be x squared. Okay, only the center term is slightly harder to find. Okay, last term is also easy. All you need to ask yourself, minus 3 times what will give you negative 18? So you can see that it's going to be plus 6. Okay, so to find the value of b, we will equate coefficient of x squared, okay, of x squared. Okay, so the coefficient of x squared in original question is 5. So we will put 5 here. Okay, then all we need to do is find, okay, when we do this multiplication, 2x minus 3 times x squared plus bx plus 6, right? What are the terms that are x squared terms? So you can see easily that it will be this one. 2x times bx, so you get 2bx squared. So in other words, 2b is a coefficient. Okay, then another one will be this one. Minus 3 times x squared, you get minus 3x squared, so minus 3 is a coefficient. So in other words, 8 is equal to 2b, b will be equals to 4. Okay, so now our px will become 2x minus 3, x squared plus 4x plus 6. Okay, so now we want to solve px equals 0. In other words, we want to solve this. Okay, so it's either 2x minus 3 0, which will give us x equal to 3 over 2, or x squared plus 4x plus 6 equal to 0. But if you look at the question now, okay, so at this stage, if you look back at the question, the only one that show that it has one real root. And we already have that one real root, which is x equals to 3 over 2. So there should be no real roots from here. So in other words, if we can show that this x squared plus 4x plus 6, right, equals 0 has no real roots, right, then we actually solve the question. So how can we show that a quadratic has no real roots? Do you recall? Yes, we find its discriminant, and then the discriminant should be less than 0. Okay, so let's go ahead and find the discriminant. Okay, I'm going to continue from here. So let's find the discriminant. So in this case, b is 4, minus 4a is 1, and then c is 6, right? So this is a. So if there's nothing in front, means a is equal to 1. Okay, and this is b, so b is 4, and c is equal to 6. So over here it has 16 minus 24 and negative 8. Indeed, b square minus 4ac is less than 0. So the above quadratic equation has no real roots. Okay. So there's only one real root, which is x equals to 3 over 2. So the only real root for px equals to 0 is x equals to 3 over 2. Okay, so x equals to 3 over 2 is the only real root, right? Because the quadratic part of the equation has no real roots. Okay, use our answers to part B and C, which are the two previous parts, to solve the following equation. Okay, so the equation given to us in this part is this. Okay, it looks complicated. Okay, by math, if you see something unfamiliar, what you try to do is you try to change it to something that is familiar to you. And the previous part, what we solve is this equation, right? Actually, okay, in the previous part, 2x squared, we solve px equal to 0, and px is equal to 2x cubed plus 5x squared minus 18, right? So what we solve is this. So now what we try to do is we try to transform this into this form. And there's already some similarities. You can see there's an 18 here, 2 here, and then a 5 here. Okay, so this one, we always use, for this term, we always try to use the law of indices to break it up. Okay, so if you apply the law of indices, you will get this, right? Okay, 2 to the power of 3y plus 1 can be expressed as 2 to the power of 3y times 2. Okay, then this one, we want to bring the 2 out, okay, the square out, because there's a square over here. We want to reproduce a square. And the 18, of course, we bring to the left side. Okay, then this one, we put a 2 in front, and then we will get this. Okay, why? We want to get a cube out. Over here, there's a cube. Okay, then we want to employ a substitution. So let x equals to 2 power y. And if you do so, you realize that you will get the equation that you solved in the previous part. Okay, so remember we solved this earlier on and we got one real root only, which x equals to 3 over 2. Okay, so in other words, when you solve this, you will get x equals to 3 over 2. Okay, and remember now what we want to do is we want to find y. Okay, so we'll ln both sides. Okay, then all you need to do is divide the ln 2 over and then give your answer in 360. Okay, I think this will be the answer, 0.585. Okay, so this is how you solve questions like this. Right, so just a recap for remainder and factor theorem, which is the main thing in this question. So to find the remainder when divide a polynomial by a linear factor, you find the value of x that will make the linear factor 0, and you sub that linear factor inside the polynomial, and what you will get will be the remainder. Alright, so when the linear factor, when if it's a factor, okay, then you will get remainder 0. Okay, by the linear thing that you divide by the divisor, actually I should say when you divide by a linear divisor, okay, it's not a factor, then you will get a number as a remainder, right?